All right, mathletes, this is the distributive law and the product law. So when we're distributing numbers, we need to remember to carry signs in front of it, and we got to distribute to every term within our parentheses. It's implied multiplication when our numbers adjacent to our parentheses. So here when we distribute, we're going to distribute negative 2x times x. So we get negative 2x squared. And then we're going to take that negative 2x and distribute it to our negative 3. Negative times a negative is positive. 3 times 2x is going to be 6x. We're going to look for like terms. We have an x squared and an x, so they're not like terms, so we don't need to simplify it any further. Expand and simplify. So now we're just doing the same process, but we're going to have some simplification here at the end. So we're going to distribute our 2 to our 3x, and we're going to get 6x. 2 to a negative 1, we get minus 2. And then on the other one, we're going to look for our sign and make sure it's a 3, and we're going to distribute that to our 5, and we're going to have a plus 15, and a plus 3 to a negative x, and we're going to get a minus 3x. At this point, I'm going to look for my like terms. So I have an x, and I'm going to combine those. So 6x minus 3x, I'm going to get 3x, and then negative 2 and plus 15. I'm going to combine those, and I'm going to get a plus 13. And there I've distributed and simplified my terms. Okay. Next example here is when we're distributing across two binomials. So what we have to remember here is that we got to multiply every term in each quantity to every term in our second quantity. Okay, so for two of them, we can see that a times c, we get that. A times d, we get that. When we take our second term, we do b times c, we get that, and b times d, we get that. Okay, sometimes I'll refer to this as our double rainbow, trying to remember that we have to distribute every term to the next terms. Okay, so here in this example, we can go ahead and see we have 2x times 3x. So 2 and 3 is going to give us 6. X and x gives us x squared. And then we do 2x to a negative 2, so I get a minus 4x. And then I look at my next term, which is a plus 1. Multiply it to 3x, I get plus 3x. And a plus 1 to a negative 2, I get minus 2. Looking for my like terms, I see that negative 4x and 3x are similar terms, and negative is larger, so I'm going to get a negative 1x. And then I just have 6x squared is going to drop down, and a minus 2. And all my like terms are combined, and I get that as my product. Okay, next example here. Same idea, but notice something interesting is going to happen because we have the same first two terms, same last two terms, but they're differing by their signs. So let's see what happens when we distribute these. Okay, so 3x times 3x, I'm going to get 9x. 3x times 5, I'm going to get a plus, and that's 3x squared. I'm going to get plus 15x. And then I'm going to take the negative 5 here and times it. I get a minus 15x. Okay, and a minus 5 times a plus 5, and I'm going to get a minus 25. When they're different here of just signs, you're always going to notice that these two middle terms should cancel out because we had a negative 5 and a positive 5. So what we're just left with is our last term and our first term, 9x squared minus 25. Okay, notice both these numbers are perfect squares, where 9 is the perfect square of 3 and 25 is a perfect square of 5. This will come up again when we're talking about distribution. Okay, next example here. So 3x plus 1 squared. We got to remember that when we're squaring a number, it's something times itself. So I always suggest rewriting this one of 3x plus 1 times 3x plus 1. Okay, we don't want to make the mistake of trying to distribute this and to square this number and square this number. It does not work like that. We have to think of it as something times itself, and that's going to require double distribution again. So 3x times 3x, we're going to get 9x squared. 3x times 1, I'm going to get a plus 3x. 1 times 3x, I get a plus 3x. And 1 times 1, I get a plus 1. Collecting my like terms, I get a 6x here, dropping down my 9x squared plus 6x plus 1 is the product there. So make sure if you see a binomial being squared, okay, that you rewrite it as something times itself, and that helps you remember that you must distribute. Last example here is just kind of mixing things up and having multiple things we're going to have to collect like terms. So again, since I see this addition sign here, I'm only going to multiply these two terms together first. So I get x times x, and I get x squared minus 3x plus 2x minus 6. And then I'm going to worry about the second term. And I'm going to distribute this here to a plus 5x and a plus 20. Last thing to do is collect my like terms. So I only have one x squared. Okay. And then I look for my x terms. So I have those there and those there. So these combined will give me minus x. And this plus a 5x is going to give me a plus 4x. And then I'm going to look for my constants. Minus 6 and a plus 20 is going to give me a plus 14. And that is expanded and simplified. That concludes our notes for tonight. Please highlight any questions you might have and bring them to class tomorrow.